Hi, hello, and welcome to what just might be your last Google Classroom Notes video of this year. Man, are we excited for that. So the last topic we are going to learn about statistics this year is standard deviation and variance. These are both measures of dispersion, or how spread out is our data. So data spread. Okay, now we're going to talk about first the other measure of dispersion we know, which is range, that tells us what is the range or the maximum and minimum values that my data falls between. So I'm going to look at two different data sets. Data set A, I have 90, 90, 90, 98, and 90. Okay, my range here, remember range is maximum minus minimum. So here my range is going to be 98 minus 90, so my range is 8. Okay, data set B, I've got 1, 6, 8, 1, 9, and 5. That's a 9, I promise. My largest value is 9. My smallest value is 1. So 9 minus 1 is 8. So these data sets have the same ranges, even though that they are very different. So they have the same range, even though that they are very different. Okay, this data, we have all of the same number and then one outlier. This data is a little more generally spread out. So the range doesn't tell us, one, how close the data is to the mean, and two, it doesn't tell us anything about the types of data in our set. So that's why we have what's called variance and standard deviation, two related measures of dispersion that give us a key point of how much do data values differ from the mean. So that's what variance and standard deviation tells. How much do data values differ from the mean, or how data points are spread out from the mean. Okay, both of these essentially show us the same thing, how spread out are the data points from the mean. The one we use more frequently is standard deviation, so this is the one that's a little bit more important than variance. Some notation for standard deviation here, this symbol here, okay, means population standard deviation. How far are the data points in the population spread out from the mean? SX means the sample population. Okay, so this is just some notation we use. We almost always use the standard deviation of the population because we care more about the population than just the sample that we took. Okay, so what does this show about the data? We've kind of talked about this here. Variance really helps us show the variation among variables in the data set. Okay, the way that we calculate it, or one way we can, I'm going to show you how to do it on your calculator. It is the sum of the data, each piece of data squared, and then we find the mean of that. Okay, what this helps us with is it makes all the values positive, so positive values above the mean don't cancel out negative values below the mean, and it helps us see the squared values make outliers even larger, so it helps us see the spread of the data. How we can calculate this, it is going to be the standard deviation squared. So it is the squared value of the standard deviation. Okay, so our standard deviation, our population standard deviation squared is equal to the variance. Okay, well, with standard deviation, it is just the square root of the variance. It's the square root of the variance is our standard deviation. Okay, what does it show about the data? Well, if we have a low population standard deviation, it tells us that the data is close to the mean, which means it is less spread out. Okay, so a low standard deviation means our data is less spread out. A high standard deviation means the data is more spread out. It is not as close to the mean. Okay, so this lets us compare within a data set, data values to data values, not just saying the difference between the maximum and the minimum. So I'm going to show you how to calculate these on your calculator. We're going to go through two examples together. So make sure you have your calculator right next to you. And hopefully you can see this. Let me turn on the light and see if that makes it a little bit better. Okay, so first thing that you're going to do, let me see if I can make this a little bit brighter. Hopefully that helps a little. First thing you're going to do, you're going to go to New Document. Okay, press Enter. Don't want to save unsaved document. First thing I'm going to do is go to where it says Add Lists and Spreadsheets. Add Lists and Spreadsheets because I have data to enter. So add Lists and Spreadsheets, and you should get this table to pop up. Okay. From there, you want to label what your data is. So if you have multiple lists, you know where to pick from. So this one says the variance and standard deviation of the following scores on an exam. Well, if this is scores on an exam, I'm going to call it E. So I'm going to go down here and just click E on my calculator and press Enter. Okay, so that is the name of my spreadsheet. I'm now going to enter my data. I've got 92, 95, 85, 80, 75, and 50. Okay, so I've now entered all my data. I'm going to press Enter. Then I'm going to click Menu. Go down to where it says Statistics. And then we're going to go to Stat Calculations. One variable statistics, because the only variable I have here is scores on an exam. So one variable statistics and press Enter. Okay, number of lists, it's one variable statistic, so I just need one list. Okay, and then X1 list is the list that you just named. So I'm going to delete what's in here. I named my list E, so that's the list that I want to choose. I don't have a frequency list, so I can just press Enter. Okay, and it's going to pop up a whole bunch of information here. Okay, the ones that we care about, okay, this is our symbol for standard deviation, this little almost theta symbol here. I care about the population standard deviation, not the sample standard deviation. You'll notice that there is a difference. So SX, that is my sample deviation, okay, or the deviation in my sample size, okay, and that is equal to, my sample one is 16.23. Okay, my actual or population standard deviation is, this is my population standard deviation, 14.82. Okay, now finally, to find my variance, remember that variance is the standard deviation squared. So my variance is going to be 14.82 squared. I'm going to grab another calculator to pop that into so that I don't have to get off my spreadsheets here. So on my other calculator, I'm going to do 14.82 squared. That gives me 219.63. Okay, so what does this mean? What this means for our population standard deviation is that on average, the population data is 14.8 units from the mean. So if I picked any data from this, or any piece of data from this data set, it is about 15 units away from the mean on average. Well, this actually calculates your mean for you as well. X bar is the same thing as mean. So this has gone ahead and calculated that for me, which is 79.5. So what this is saying is each of these data pieces on average, not precisely, but on average, is 14.81 units away from 79.5. Okay, from the mean, or 79.5. Okay, so this case, this is a high standard deviation. This is a pretty high value for a standard deviation. So we know that this data is somewhat spread out. Okay, so standard deviation is the one we really look at. Variance is just the standard deviation squared. So we took each data set, what it really did is took each data set, found how, or each piece of data, found how far away it was from the mean, squared it, and added them all up. So that's why we take the square root to find our population standard deviation, which means on average the population data is 14.81 units away from the mean, which is 79.5. The data is somewhat spread out. Other thing, I'm going to show you some handy tricks on your calculator. X bar is mean, so it calculates the mean for you. It also gives you the minimum, quartile 1, median, quartile 2, and maximum. So this can help you sketch a really quick box and whisker plot without having to do all the calculations. So that's what I'm going to do. I've got 50, we'll make that 60, 70, 80, and 90. I see my minimum is at 50. My quartile 1 is at 75. My median is at 82. My quartile 3 is at 92. And my maximum is at 95. Okay, so I can sketch a quick box and whisker plot. What you can see here, okay, the box and whisker plot shows you that the data is really spread out below quartile 1. Because remember, this contains 25% of the data, this contains 25% of the data, this contains 25% of the data, and this contains 25% of the data. So 75% of the data is really concentrated. We just have one random piece of data or one outlier way down here, which is why our standard deviation is pretty high. The data is really spread out in this between the minimum and the lower quartile. So again, those are some quick data points for a box and whisker plot if you don't want to have to calculate it by hand. Okay, last one I'm going to show you, same calculations, but this time we have a frequency table. This says the table below shows the number of tardies for students over a 4-month period. Find the variance and standard deviation. So this is the number of tardies, and then here's the frequency. So there were 2 students that had 5 tardies. There were 3 students that had 6 tardies, so on and so forth. Okay, so we're going to calculate the variance and standard deviation. Again, we go to New Document. Don't want to save this. I don't need this data list anymore. And then Add Lists and Spreadsheets. Press Enter. I'm going to call this T for tardies. So I'm going to call this T. Press Enter. And this I'm going to call frequencies. Did I type that in right? T and Enter. Yes. And then this I'm going to call frequency because this other column of data is the frequency of these occurrences. So I'm going to call this FRQ. So FRQ for frequency. Okay, because that's how often those data points occur. Oh, it's because I have to put the data in first. Sorry. Let's go to New Document. I have to put the data in first. That's why it's mad at me. Okay, so our tardies on this side, 5, 6, 7, 8, 9, 10. And we're going to name that, like I said before, T for tardies. But now it's going to actually do it because I have data entered. I'm going to type in my frequencies next. I have 2 people with 5 tardies. 3 people with 6 tardies, 2 people with 7, 2 with 8, 1 with 9, and 1 with 10. And I'm going to call this list FRQ because it is the frequency. So FRQ here. Okay, I'm going to press enter. Now you're going to go through essentially the same process: menu, statistics, stat calculations, one variable statistics. Okay, a number of lists, 1. Now we just got to change a couple things here. My list name is T, right? T is the number of tardies. My frequency list, the one below it, I called FRQ. So that is my frequency list. So the only thing I change here is I now have a second column which gives frequencies, so I have to name that frequency list as well. I'm going to press enter, and now it's given me this data here. I know that the mean is 7, so the X bar or mean is 7. These values I don't care about just yet. My sample population deviation, so SX is equal to 1.61. My population standard deviation is 1.54. Remember, that's the one that I really care about. And then I've got my minimum and maximum values, things like that. To find my variance, I do the standard deviation, or 1.54 squared. So 1.54 squared gives me 2.37. Okay, and what this is telling me is that on average, the population data is 1.54 units from the mean. Okay, so if I pulled any random pieces of data, on average, it would be about 1.5 units away from the mean. So the data is very concentrated or not spread out. Okay, remember, because a low standard deviation, like 1.54, means the data is less spread out. So it is more concentrated. Okay, notice how this is a much better picture of what the data looks like than just saying the range is 10 minus 5. So the range is 5. Well, that tells me the difference between the maximum and minimum, but it doesn't tell me about how far each data point is from the mean. So standard deviation is just a much better picture of the entire data set, not just the extreme end values. Okay, again, if I wanted to make a box and whisker plot from this, I have the minimum value, the quartile 1 value, the median, the quartile 3 value, and the maximum value. So I could use these and sketch a quick box and whisker plot if you wanted to, which I can do really quick. If I got a box and whisker plot here, I'm going to do 4, 5, 6, 7, 8, 9, 10, 11. My minimum, which you can't see, my minimum is 5. My quartile 1 is 6. My median is 7. My quartile 3 is 8. And my maximum is 10. Okay. So notice for this box and whisker plot, again, the scales are different on these, so that's one thing to compare. But notice in this box and whisker plot how it is much more concentrated, and each quartile is about the same size. Each quartile is about the same size. Okay, so this one is super, super spread out. These are all about the same size, meaning the data is much more concentrated. Okay, that is all I have. Man, what a time to be alive when the last Google Classroom video of the year for notes is being done. Thank you all for attending this. As always, like and subscribe.